Okay, today we're going to be talking about solving quadratics using the square root method. So we will look at real solutions, and we're going to use this method when the quadratic equation can be written as ax squared equals c. And notice there is no x term. Your a coefficient is going to be on the left side of the equals, and then you may have to move your c, your constant, over to the other side so it will be after the equals. But one thing you need to make sure of, when you move your c over, c should be positive, or else you will not get a real solution. So there's just three simple steps. So you're going to rewrite as ax squared equals c. Again, you may have to move your constant over to the other side, move it over after the equals, and again, your c should be positive. You're going to divide both sides by your a coefficient. That is only if a is not a 1. So if you have a 3 or a 5 for your a coefficient, you want to divide by a because you want 1x squared. Then you're going to take the square root of both sides. Now when you take the square root of both sides, you need to remember that you are going to end up with two answers. One is going to be positive, and one answer is going to be negative, and you'll see when we start working problems what I mean. So this is why you have two of those symbols on the front of your notes. You have a positive sign and you have a negative sign to remind you that you should have two answers. So now we're going to look at examples. And your first example is I have x squared minus 75. Well, if I move my constant over to the other side, I'm going to end up with x squared equals 75, and my constant is positive, and I have an ax squared term before the equal sign. Notice my a is that invisible 1, so I can't divide by 1, it won't change anything. So what I'm going to do now is, in order to cancel out a power of 2 or a squared, I'm going to take the square root of both sides. And this is where the square root method comes in. Now, we learned how to simplify radicals in a previous lesson, so what I'm going to do is I'm going to rewrite 75 as the product of prime numbers. So I'm going to divide up by 5, divide out by 5 again, and divide by 3. And so my prime numbers that break down 75 are 5 times 5 times 3. So I'm just going to rewrite that in here, 5 times 5 times 3. And now, if I use my index, which is an invisible 2, I can make groups of 2. Well, the only group of 2 I can make is with my 5s. So I'm going to rewrite 75 as 5 times the square root of, and I have a 3 left underneath my square root. Okay, so let's look at what happens to, so that takes care of my square root of 75. Let's look what happens to the square root of x squared. Well, just like addition and subtraction are inverse operations, and multiplication and division are inverse operations, square root and powers of 2 or squares are inverse operations. So they actually cancel each other out, and I'm just left with x. Now, if you remember from the front side of our notes, when we take the square root of a positive integer, of a positive value, we are going to end up with two answers, a positive and a negative. And what that really means, that simply means that x is equal to a positive 5 times the square root of 3, and x is also equal to a negative 5 times the square root of 3. And those are my two solutions. Just a note, on a test, or maybe even on your STAR test, you may see them combine both answers into one answer using this plus minus combination symbol. It simply means one is positive and one is negative, but I want you to get used to seeing the combined symbol, but just know they are two separate answers. So now let's look at our next example. I've got n squared plus 4 equals 40. Again, I'm going to move my constant over to the other side, and I've got n squared equals 36. I want to rewrite, to undo my squared, I'm going to take the square root of both sides. And now I want to simplify my radical. So the square root of, 36, let's see what prime numbers, that's going to be 3. 3 again, which is going to leave me 4. which would be 2, and then divide 2 by itself to get a 1 for my candle. So my prime numbers are 3 times 3 times 2 times 2. 3 times 3 times 2 times 2. Now some of these you can get to where you start doing these in your head, which is completely fine, but if you need to write out your birthday cake method, I recommend that also, just to make sure you get the correct prime number values. So I can make a group of 3s and a group of 2s, because remember our index is an invisible 2. So that is going to mean I can pull out 1 3 and remove 1 2, so that would make 6. And so now I'm going to cancel out my square root and squared, so I'm just left with n equals. And when I take the square root of a positive whole number, I get 2 answers. So this really means n is equal to a positive 6, and n is also equal to a negative 6. Again, you can check this by using the graphing method, which we'll look at here in just a second to check our work. Okay, so now let's look what happens when our a coefficient is not a 1. So again, we're still going to move our constant to the other side. So we're going to have 3x squared equals 27. I still want to make sure that my constant is positive. We can't take the square root of a negative number just yet. You haven't learned those skills. That will come up in Algebra 2. And since my a coefficient is not a 1, I am going to go ahead and divide off, because I do want to end up with 1x squared before the equal sign. And 27 divided by 3 is 9. And again, I want to unsquare x, so I have to take the square root to cancel out a power of 2. And so that will leave me with just x equals. And now I need to simplify my radical for 9. So I'm going to go over here at 3, and I can divide out by 3 again, which will leave me a 1 on my birthday cake. So my prime numbers that break down 9 are 3 times 3. And again, I'm looking for groups of 2 because that's my invisible index on these problems. And that means I can remove one group of 3's from my square root, so that's going to leave me with the 3, and my answer has to be positive and negative. So really, my answer is x is equal to 3, and x is equal to a negative 3. I would be looking for the answer choice with both of these answers listed out, or with the combination plus minus sign in front of the 3. All right, so now I've got 2x squared minus 2 equals 6. Again, all the constants get moved to after the equal sign, so I have 2x squared equals 8. Since my a coefficient is not a 1, I have to divide off by a, divide both sides by a, so that's going to leave me with 1x squared equals 4. And to cancel out my square root, or my power of 2, I'm going to take the square root of both sides. So these will cancel out, and I'm just left with x equals, and I need to simplify my radical of 4, so I want to see what prime numbers I can rewrite 4 as. So that would be 2. So my prime numbers that I can rewrite 4 is the product of 2 times 2. And again, I want to make groups of 2 because that is my index. So now I can move out one group of 2's, and it's going to be a positive and negative. So x is really equal to a positive 2, and x is equal to a negative 2. Okay, well, what would that look like if I was trying to check this on my calculator before we move to these two examples? So here's what we need to do. So I'm going to go back to the first example. So if you go to y equals, it's clear memory. The first thing you want to do is you want to make sure when you type it in your y equals screen that all of your terms are on the same side of the equal sign. Even though we move it over to take the square root, when I type it in y equals, all my terms, my a x squared term and my constant term have to be on the same side. So I'm going to type in x squared minus 75, and I'm going to hit graph. And remember, I'm looking to see where does it cross the x-axis. And I can see it crosses the x-axis on the negative side of 0 and the positive side. Well, if you look at our answers, we did get a positive answer and a negative answer. I just don't know exactly where on the number line 5 square root of 3 falls and negative 5 square root of 3 falls. So once I figure out what those decimal values are, I can then see, am I on the right track? so that I am in the ballpark with my answers. Those do make sense. Okay, so let's look at the next one. Again, if you want to type it into y equals, you have to get all your terms on the same side. Well, I want to move this 40 back over if I'm going to type it in my calculator. So for y equals, in my calculator, I would have n squared. I would move the 40 over and it would be minus 36 after I combined it with the 4. So x squared minus 36. And I'm going to hit graph. And now I want to look and see. Again, I'm showing I should get 2 answers because it crosses the x-axis 2 times, twice. Once negative, once positive. And it looks like I can pretty much guess 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, negative 6. But I can check these in my graph. Remember, solutions are when y is 0. There's a 0 at positive 6. Well, now let's go up to x is negative 6 and see if we have a 0. Okay, we do. And so those are my 2 solutions. All right, let's check the next one. Since it started off with all my terms on the same side, I can simply type in 3x squared minus 27 and hit graph. And again, I'm expecting 2 answers, one negative and one positive, and it appears they cross at 3 and negative 3, but I can check in my table. Negative 3 is the solution, and positive 3 is the solution. And look, we got 2 solutions, one at negative 3 and one at positive 3. All right, so now this is kind of like the example, the second example, where we need to move our 6, our constant, to before the equal sign so that we can type it in y equals. So y equals, it would be 2x squared. I'd move the 6 back over and it would be minus 8. And again, this is only for graphing solution. You want all your terms on the same side. And we got 2 solutions, one negative, one positive. We got 2 solutions, one negative, one positive, and it appears they do cross at 2 and negative 2, but if they're whole numbers, I can check in my table because I can see those solutions very easily. Negative 2, there's a 0. Positive 2, there's also a 0. So yes, our solutions do check.